All right, we're diving into a huge topic today. How do you take a massive, sprawling digital world and stop it from turning into total chaos? Let's get into it and see how Google Cloud builds a system to keep everything in order. So here's the real problem, right? You've got maybe thousands of virtual machines, you've got databases, you've got users all over the place. How on earth do you keep track of it all? More importantly, how do you make sure the right people can get to the right things and only the right things? It sounds kind of impossible, but it turns out there's a blueprint for it. And that solution is the Google Cloud Resource Hierarchy. The best way to think about it is like a blueprint for a giant corporate campus. I mean, before you even start digging or hand out a single key card, you need a plan, right? You need to know where every building and department is going to go. This hierarchy, that's the plan. Okay, so this hierarchy is actually really simple, but incredibly powerful. At the very top, you have the organization node. That's the whole company, the entire campus. Then you use folders to group things by department, let's say finance or engineering. Inside those folders are projects for all the different team initiatives. And finally, you have the resources, the actual servers, the storage, the tools people use. Now here's the most important part. Policies and rules flow downwards. A rule you set at the department level automatically applies to every single thing inside it. It creates order from the top down. Now, when we talk about projects, it's super important to know that every single one has 3 different identifiers. First, there's the project name. That's for us humans, right? Something like Q4 marketing campaign. You can change it and it doesn't have to be unique. But then you have the project ID. This one is globally unique, and once you set it, you can never change it. It's immutable. That's what the system uses to know exactly which project you're talking about. And lastly, there's a project number, which Google assigns behind the scenes. It's also unique and immutable. So we've got our blueprint. The campus is all planned out. But a building without locks on the doors isn't very useful, is it? In Google Cloud, the security system, the locks, the keycards, the whole shebang, is called Identity and Access Management, or IAM for short. At its core, what IAM does is actually pretty simple. For any action that anyone or anything tries to take, it just asks 3 basic questions. Who is asking, what do they want to do, and what thing are they trying to do it to? And this is that 3-part question in action. Every single security policy in IAM has these 3 pieces. The who is what we call the principal. That could be a person, a whole group of people, or even a program. The can do what is the role, which is basically a collection of permissions. And of course, on which resource is the target, the actual server or file they're trying to access. Okay, now this is one of the most critical rules in all of cloud security. You're going to have policies that allow people to do things, and you're going to have policies that deny them from doing things. If there's ever a conflict, if one rule says yes and another says no, deny always wins. This is your ultimate safety net. It means you can give a team broad access to do their job, but then specifically deny 1 or 2 really dangerous actions, and you can sleep well knowing that deny rule will always be enforced. Let's dig a little deeper into that can do what part, the roles. If IAM is the security system for our campus, then you can think of roles as all the different kinds of keys you can hand out. And just like with real keys, some of them are master keys that open every single door, while others might only open one specific office. You've basically got 3 main flavors of roles, and they get more and more specific as you go down the list. We start with the really broad, basic roles. Then we get more focused with job-specific predefined roles, and finally, we can get laser-focused with custom roles for total control. So, the original basic roles are simple and super powerful. Owner has the keys to the entire kingdom, full control. Editor can change and modify things, and viewer, well, they can only look, not touch. But here's the caution, and it's a big one. These are like master keys for an entire project. They often give people way more power than they actually need. And that's exactly why predefined roles exist. They're like a key card that's programmed to only work for a specific job. So, for example, the Compute Engine Instance Admin role bundles up all the permissions someone would need to manage virtual machines. Starting them, stopping them, deleting them, but it gives them 0 permissions to do anything else, like mess with the databases or look at billing info. And this all leads to one of the most fundamental ideas in modern security, the principle of least privilege. The idea is really simple. You should only give people the absolute minimum amount of access they need to do their job, and not a single permission more. It's the single best way to reduce your risk. And custom roles, they are the ultimate tool for making this principle a reality. With these, you can literally handpick individual permissions and bundle them together to create the perfect, tailor-made key for any job you can imagine.
Maybe you want someone to be able to start a server but not reconfigure it. You can do that. It's maximum security through total flexibility. So far, when we've talked about the who, we've mostly been talking about people. But in the cloud, it's not just people who need access. A lot of the time, programs and applications need to do things on their own. So how do they get an identity? Well, that's where service accounts come in. You can think of a service account as an ID card, but for a piece of code instead of a person. And because an application can't type in a password, it uses super secure cryptographic keys to prove who it is when it needs to access other cloud services.
Let's just walk through a quick story to see how this works. Imagine you have an app running on a virtual machine, and it needs to save a log file to cloud storage. Instead of a person having to log in and do that manually, the app uses its own service account identity. It presents its special key to cloud storage, proves who it is, and boom, if it has the right permissions, it's allowed to save the file. It's all secure, and it's all completely automated. Okay, we've built the structure, we've set up all the security. Now, how do you actually interact with this perfectly organized digital world? Well, there are a few different ways, and it really depends on what you're trying to do. And Google Cloud really gives you a tool for every possible workflow. If you like a visual point-and-click web page, there's the Cloud Console. If you live in the terminal, there's the command line. If you're a developer, you can use the APIs to control everything with code. And yep, there's even a mobile app for managing things when you're on the go. There's an entry point for everyone. So, after all of that, what's the one big idea you should walk away with? It's the power of one. One single, consistent hierarchy that you can use to structure everything. It's what brings order from potential chaos. And that brings us to the most important point of all. You simply cannot have real, effective security without a clear structure. That logical organization is what lets you apply all those IAM rules and policies with confidence. A well-organized environment is a secure environment. So we'll leave you with this thought. Now that you have the blueprint for the campus and the system for managing all the keys, what amazing things would you build? And, just as importantly, who would you decide to give the keys to? Thanks for watching.